Hello everyone and welcome back to another video. So this video is back again at the test bench. So again, we only have the onboard audio from my OnePlus 7T Pro because, well, the test bench is still in a very not great position to hook up the audio equipment. And today we're taking another look at my two reference GTX 580s. So if you watched the latest videos, you know that I now have two reference design GTX 580s in my collection. You see these do look a bit different. This one's got a green PCB, this one has a black one, this one is using yellow capacitors, this one is using black ones, and then the sticker, like this one has a sticker, and then this one is just... It doesn't, because I got rid of the sticker, because the sticker on that card was pretty bad condition, whereas on this it's looking fine. But functionally, these two cards are identical. These two use the same cooler, the same PCB, the same graphics chip, the same memory. It's all the same. And so these are a perfect candidate to show the effect of silicon lottery. So just as a small explanation what silicon lottery is, and then later we're going to get into the demonstration of how it looks like in practice. So obviously this video is not aimed at the more in-depth people that I usually make videos for. This is a pretty basic video. It's basics of overclocking. So silicon lottery is because, like, I see a lot of people going into a Discord channel, like I'm pretty active on the Linus Tech Tips Discord, and I see a lot of people going into the overclocking channel and asking, how many volts do I need for 5 gigahertz on my i9 9900K? And the answer is always, it's not that simple, because your CPU will probably need different voltage from every other 9900K out there. And that's exactly what silicon lottery is, because silicon lottery describes how every piece of modern silicon, so what your core and your memory is made of, is slightly different, because the manufacturing process is so small. Like modern like Ryzen 3rd Gen CPUs have transistors that are only 7 nanometers large. These older cards are still at 40 nanometer, but like 40 nanometer is still very tiny. And so these huge, very complex and just high-end, highly developed chips, you literally can't make them without some kind of imperfections. And because of these imperfections, every single chip, be it the exact same one, both of these cards have the same GF110 chip in them. These will behave differently. They will not overclock the same. You could theoretically get two pieces that are so closely aligned that basically, practically, they overclock the same, but the chances are you're going to get some that are different, as is the case here, which I'm going to demonstrate. So, what silicon lottery just describes is your piece of silicon, which technically is identical to every other piece of silicon there is. Say, I have an i7-8700K in my main system. My friend also has an i7-8700K, but my i7-8700K runs 5.1 gigahertz at 1.35 volts on a weaker motherboard than my friend has. My friend has not only that better motherboard, he runs his CPU, or did run his CPU, actually don't clocked it, he did run it at 5 gigahertz flat, so 100 megahertz worse than my 8700K at 1.4 volts, which is more voltage than my 8700K needs. And that again is silicon lottery, because my 8700K is a pretty lucky one, and it's a pretty good one, whereas my friend's 8700K is more of a typical sample. So my 8700K is both going faster and needs less voltage to run at that clock. And yeah, that's pretty much it. And I'm going to demonstrate it with these two cards. So both of these do run the reference NVIDIA BIOS. So the maximum voltage you can set is 1.15 volts. And the maximum fan speed on these is actually 85%. Both of these have the same cooler. So they're running the same voltage with the same amount of cooling, with the same, the VRM section is the same, the memory chips are the same, because like you can get Hynix and Hynix and Samsung chips on these cards. Both of these are using Hynix. So there's also no difference there, because the Samsung chips usually do a bit better in overclocking. There is one actual difference between the two cards though, and that is that this Zotac card right here, this is modded. As you can see, there are extra capacitors on here, and then there's a potentiometer right here. So this card is modified, and those mods do increase your overclocking capabilities. What you're going to see, however, is that actually this card runs faster, because this one is a winner in the Silicon Lottery, and this one is a pretty big loser. This is actually the worst GTX 580 I have. And this one, while probably not the best, is a pretty good one. And so what I'm going to do right now, I'm going to take the green one, which is the better one, I'm going to put it into my test bench. I'm going to show you how it runs in a benchmark at the overclock that it can sustain. Then we're going to switch to the second card, which is actually running at an advantage because of the mod right here. And we're going to try to run the same clocks at the same settings of voltage, fan speed, and all that. And you're going to see that this card will crash, while the other one will be completely fine. So yeah, let's adjust the camera angle, and I'm going to whoop. There's the test bench, and yeah, I took the back panel off because I was doing some cable management. Okay, can we turn the light on? That helps a bit. So okay. Right, let's get the connect. Okay, display is hooked up. Now we need power. And we can turn it on. So let's get to the screen, turn the light back off, adjust the camera a bit. And here we have the card firing up. Also, when I turn the PC off, you might see the desktop of another machine, because Zoros Alpha, which is my old test bench, which is now a dedicated game server host, that's also running. So you might see the desktop of that, because both of these machines are connected to this, one monitor. So what we have here is we're going to max the fan speed. We are at a maximum for our voltage, and I know that this particular card can go to 950 megahertz and 2350, no, not 20, oops, 2350 on memory. And you probably can hear the fan now, but for the sake of comparison, we're going to just leave it at static 85%. So that's the overclock for this card. So 950 megahertz on the core and 2.35 gigahertz for the memory. And if we now go into Heaven benchmark and run that, this is actually going to be, I think now we don't have to run the entire benchmark, but like half of it, because that's about the time the other card needs to crash. So let's just go to scene 13 of 26. So you can see right here we are at 950 megahertz core. Yeah, okay, there's like 1 megahertz less because the monitoring software picks it up slightly differently. The CPU, if it's relevant, it's a Ryzen 5 1600 running stock at the moment, so that's why we have 3.4 gigahertz. It's not really like the CPU is going to be a bottleneck here. This is a GTX 580, and we're running a graphics test, so no issue really there. And you will see that the temps will rise a bit. I think up to 70 degrees, sometimes 74, depends on how hot my room is. It's rather cold right now, but it could be colder. And me sitting right next to the test bench blocks off a bit of the airflow, so it might get a bit toasty. But I actually didn't run the whole benchmark, but like I pre-tested it, and it's like the other card by this point, I pre-tested it before I started this video. The other card would have crashed by now. Oh, actually, there's a memory artifact on here. Okay. So it wasn't 2350, it was 2325. Yeah, okay. Because you could, for a short period of, for short you could see like a colorful, like, almost like a light looking thing on the screen. That's a memory artifact. That's like indicating that your memory is running a bit faster than it should, because it can't keep up, and it's producing errors that result in these colorful lights on the screen. And that might be, because the card is getting pretty hot right now. It's getting hotter than the last time when I tested it, and temperature is a part of overclocking stability. The hotter something is, the slower it will go, because, well, when things get hot, they just get unstable. So, oh damn. Yeah, that's not good. So we're back in heaven. Turns out that, yes, my room is slightly too hot right now, and since my overclocks are like really pushing the card to its limit, it ended up actually not being fully stable with the temperatures that it went to. But for the purposes of this video, this is actually okay, because the other card will crash much sooner, like at least if it does run like the time when I tested it before the video. You know, it's always a thing when you're recording and when you're not recording. But yeah, so we're back with the card, but now I'm going to switch to the other card, which again, because of the capacitors right here, is running at an advantage. So you would expect, assuming that Silicon Lottery, like if Silicon Lottery wouldn't exist. Okay, let me get the camera over there. Let's turn the light back on. So if you would assume that Silicon Lottery doesn't exist, you would also think that the other card will run faster, because you would assume that every GTX 580 will overclock the exact same, and when I now modify it with extra capacitors and potentiometers for more voltage, you would expect that the card runs faster. And I'm going to show you that it doesn't, because every card is different in how it overclocks. So let's get this card back. Let's get this card in here. And let's start again. Turn the light back off and get to the screen. Might take a while. Yeah. Actually it's booting up now. Or not. It's boot looping. Oh, yeah. That might be it. I forgot to connect the cable. Yeah, there we are on the desktop already. And we can see we still have the same clocks as the last card, and I'm actually going to bump it back up to 2350, because it did run, it just artifacted a bit. And I know that the core and the memory on this card are worse than the other one. The memory is just, oops, not 3D Mark. Yeah, let's run Heaven. I know for a fact that like the memory is only slightly worse than the other card, but the core is pretty substantially worse. Now, in the test run before the video, the card completely crashed the system when we got to the airship, to the airship scene where it goes like for flyby. Not this one, the other one. And it should start a memory artifact once it's going, like once the heat is high enough. We're still below 60 degrees here, so it takes a while to just get up with the heat, which is why the other card crashed actually, because it's hotter right now than it usually is, like when I test them. Actually, even though, yeah, okay, you see it's starting to artifact here. This is sooner and a lot more artifacts than the other card had. So we can see the memory is even less happy with this high clock. And let's say we turn it down like the other card as well. The memory is still doing it, whereas the other card stopped doing the memory artifacts. And about here is where it crashed in the test run. So since I'm recording, apparently I'm not getting the result I would have gotten if I wasn't recording. But pretty much now the card should just, like last time it gave me a blue screen. Not like your emoji, yeah, that exactly. Just a completely blue screen. Not a black screen like the other card, just a static blue screen, and this is not coming back. I didn't look at the temperature actually, but like this crashed a lot sooner than the other card. And yeah, so there you have it. You can see all these capacitors, like all the extra capacitance that we have put on the VRM, which does help keep up the minimum voltage. We have a potentiometer right here. Actually, that's not doing anything. I've deactivated the volt mod for this, because that volt mod is for the memory, and Hynix memory does not like to be overvolted. So that's actually not doing anything, but the capacitors are helping the card, like the core and the memory, to keep the minimum voltage up. If you don't know what I'm talking about, you can look up from actually Hardcore Overclocking some of the oscilloscope videos that he made. There you get a better idea of how the voltage that comes out of a VRM looks like. But for this video, yeah, I just wanted to make a short demonstration of Silicon Lottery. So we've seen, even though this card crashed, yes, it crashed as well, but please just take my word for it that it doesn't usually. Like, it actually passes the test. It's just getting slightly too hot. If you can keep it at 70 degrees, this card will happily pass the test. This one still won't. Like, I pre-tested this. I've seen it in the final overclock. Like, the final overclock for this was like, yeah, it was the 950 and the 23, 25, 2350, like depending on temperature, for this card, which is pretty high considering it's a reference blower card. And for this card, the final overclock was 2300 flat on the memory and 915 megahertz on the core. So that's 35 megahertz less than this card. So yeah, these are the clocks that I got this card to completely pass the stress test, like the benchmark, without artifacts or crashing. So yeah, and we're just gonna turn this one off because the fan noise is annoying. And yeah, there you have it. That's Silicon Lottery in action. So if you have something you want to overclock, and you want to know how much voltage it needs for a given clock, you're gonna have to find that out yourself. And don't be afraid to have your thing crash on you. Like there's with graphics cards, there's basically no risk at all. Just restart your PC, like press the reset button or just do a normal restart. Usually the driver recovers. Like seeing a hard crash like this is very uncommon. So usually the benchmark just closes and you're back on desktop. For CPUs, having those crash because they crash with a blue screen, you can potentially like corrupt your operating system with that, but like in all the time that I overclocked, that never happened to me. It's very, very unlikely. Like just if you feel unsafe, just make a backup of important files before you overclock, but like realistically that's not gonna happen. So yeah, if you have something you want to overclock, every CPU, every graphics card, every RAM stick behaves slightly differently. Because, well, these hardware nowadays is so complex that you can't avoid slight imperfections. And these slight imperfections are what determine how good your overclocking is. Because the less imperfections you have, the higher you can push that clock without throwing extra voltage at it. And yeah, like another good example of that would be my RTX 2080 Ti. I do have one in my main system. It's water cooled, and I do know someone who also has a 2080 Ti that's water cooled, and his 2080 Ti does so much better. Like his core, with a little bit, with tinkering with it a bit, he got up to 20 to 20 megahertz core, I think. The best my card can pull is a 2085, so that's more than 100 megahertz less. And then the other extreme is my 2080 Ti can just max out the slider for memory, like plus 1500, maximum that MS Afterburner can apply. My card runs it. I have yet to find a 2080 Ti that does it as well. So my 2080 Ti, for example, has really, really, really extremely good memory and a pretty potato core. Because most Turing cards can at least do 2100, my card can't. And yeah, so before this video gets too long, I think we're over 20 minutes already. Yeah, so Silicon Lottery, short version. Every piece of hardware is different. There is no universal, this will work for a given part. Every part behaves differently, every part overclocks differently. And yeah, so finding out what you need is just trial and error. Test something, if it crashes, increase voltage or change other settings that will increase stability, and then test again. And sometime later, you're going to get to settings that are stable. And if you stress test them properly and they pass the tests, you can, that's your overclock. Like you can start using that. And yeah, so that's the end of this longer than I hoped it to be demonstration video about the basics of overclocking, what Silicon Lottery is. I think I'm going to make more entries into this series. So not the really that much advanced stuff, some basics. So if someone asks in a Discord chat, so I can just basically dump the video on them, because explaining it to every single person that asks is really, really, really not the thing that I want to do. Like, not to be rude, but like, you can watch a video. And yeah, so before I ramble on for too long, this is it. This is the video. Thank you all for watching. Hope you enjoyed, and we'll see each other next time. Goodbye.